In a previous video, link in the description, I gave a diatribe about how you should know how to prompt, but do it as little as possible. And I wanted to work through a more concrete example of how you could use a platform like DSPy to do this. And even though Omar Khattab says DSPy, I'm going to continue calling it DSPy because I think it sounds better. This is an alternative to prompt engineering, and I think it's one that's useful to know about. In this example, I'm going to walk through how to use a RAG pipeline to generate input to a Muppet model, and then I'm going to use a custom objective function to score not just how good the answer was, but how well calibrated the system is. So just to walk through the steps, the first step is RAG. Question comes in, we try to generate a query that finds a good piece of evidence to help answer the question. Given that information, we'll try to generate a guess to the question, and then looking at the context that we got from RAG, the guess that we generated from the context and the question, we will try to generate a real valued number that says, how likely are we correct? The first thing that we need to do is we need to set up our information retrieval system. I often use the example of trying to answer quiz bowl questions. So here we're going to use sklearn implementation of TF-IDF retrieval in a class called TF-IDF guesser. If you take a look at the link to the homeworks below, you can see how that got implemented, but it's a really simple TF-IDF system for retrieving questions. And it scales to hundreds of thousands of documents. DSPy does have resources for using FICE and things like this, but I found it was super slow and I wanted to use my whole data set, so I used this instead. So this is just code to load the retriever from a pickle file that we've saved to disk. We'll be using this in just a minute. The first step is we need to tell DSPy how to generate a query. You need to take the question as input, and then given that input, generate a search term that can find similar questions in your history of quiz bowl questions. And so, for example, if you have the string, he wrote about being indigent in 2 European capitals and down and out in London and Paris, you might say, he wrote means that this is an author, so let's try to find author down and out in London and Paris. And because TF-IDF ignores words like of, we'll leave that out, it's unimportant. So this is what it should ideally be doing. Who knows if we'll actually get there. And then you need to generate a guess. So you get some search results out of your TF-IDF system. Yeah, maybe here we kind of get unlucky and we get something about Jack London instead of the city of London. We tell our system, hey, yeah, create a chain of thought system that takes question and context and generates a string guess. And so here it generates a guess Samuel Clemens. Now that we have a guess, we need to generate the confidence for our guess. And so here we basically say, all right, you get to take a look at everything that comes in. You get the question, you get the query, you get the context, you get the guess, and you need to generate a confidence. And so the default field, because we're doing prompting for everything, is going to be a string, but we don't want the confidence to be a string. We want this to actually be a float. So we tell DSPy, hey, confidence should actually be a float. And so then we get an output like 0.27, and that's kind of what we want. We want the confidence to be low when it's wrong. We have a guess and a confidence. How good is it? And so let's define a custom objective function that scores this. If it was wrong, then we square the confidence and put a minus sign in front of it. And so this means the more confident you are when you're wrong, the worse the outcome. If it was correct, then we first give it a bonus, just say, hey, good job, you got it correct. And then we take the confidence and we square it and add that to the bonus for just getting the correct answer. The actual logic for determining whether the answer was correct or not is using a simple function to check whether it's roughly similar. We could use the pedants package, link in the description, if we want to do something a little bit more complicated. DSPy also allows you to use an LLM as a judge, but then you have to, again, define a prompt to tell it how to judge the examples. To be clear, the setup is not perfect. You always discover things after you run it that you wish that you had done better. And two, I wanted to leave some room for students to improve on this. One thing that we can do to improve this is to get the RAG signal into this eval function somehow. Like, yeah, hey, is the answer in the context that we retrieved from RAG? If we did, hey, that's a good thing. We should probably get a bonus for that. As it is, we're only kind of scoring the final outcome, but like there should be more incentive for the query optimization to happen well. One thing that we could do is give more clues for the calibration that it could use to figure out, hey, should I trust this or not? So for example, did the RAG documents that you find support the answer that you gave? If so, you should get a higher score. We have each of our individual ingredients, and so now we need to put it together. The signature for our final result is going to say, hey, we're going to give you a guess with some context, and we're going to output a confidence. We're repeating stuff from before because we want that in our final output. This is useful not just for the metric function that I just talked about, but also if you, say, want to plug this into a downstream buzzer that decides whether to trust the confidence or not to buzz in a game. Now that we've defined our signature, we need to put the pieces together in actual Python code to execute it. And so this is called a forward function, a lot like PyTorch. This is intentional. And so here the query comes in from our input. We're going to create a context by going through each of our retrievers. I only set up one retriever to go through old Quiz Bowl questions, but you could add another retriever to also go through Wikipedia or something like that. Given that input, you generate your guess, and then given the guess, you generate your confidence score, and then you return that. So remember, that ain't all. In addition to creating a sequence of procedures to get to your final answer, you also need to score it somehow. To score it, you need to have the metric that I talked about, but you also need to have examples. Did this get the right answer or not? Was its confidence correctly calibrated? To generate examples in the format that DSPy expects, we created a little static method function to format them in the way that DSPy is looking for. Once you have examples that we load from a JSON file, we turn those into examples using the function that I just showed you, and then we run the evaluate function that DSPy provides, and we tell it what dataset we're evaluating on, how many threads to use, whether to display the progress, and whether to give a summary of the results. And yes, of course, let's show 10 examples. Now, there are a lot of magic numbers here. I want to go through them just to make it clear what's going on here so that it's more transparent. When I load in the data, I tokenize it by sentence and then remove the last sentence. Why did I do that? Because these are Quiz Bowl questions that go from difficult clues to easy clues, and if you have the really easy clues at the end, it's too simple for just about every model. I tested this on Gemma 3-4 billion, so even that too easy for this model. Removing the last sentence made it a bit more challenging. It was getting around 50% accuracy, which seemed good to me. So 129, our dev set had 1,129 questions, so I thought, well, let's just use 1,000 for the actual DSPy tuning, and then we'll use 129 as our final held out dev set. 1,000 just seemed like a nice round number to me. And so why 5 threads? I found that if I used more on my Mac Mini, it caused me to have too many open file exceptions. It gives us this nice summary of results. We have the question, the correct answer, the guess from our system, and then the score. If you have a negative score, it got it wrong. If you have a positive score, it got it right. The higher the positive score, the more it was correctly calibrated. The smaller the negative score, the more it was incorrectly calibrated. And it isn't doing a very good job here because most of the scores are around 0.9. And so this suggests that the original confidence was still around 0.9. We do have some good examples here, so that we have one score for the Texas annexation that is negative 0.57. That's actually not so bad. And then we have a really nice confidence when it said, I cannot answer. We have a really low confidence, so hey, good job there. Got it right off the bat, and insofar as that it recognized that it didn't get the right answer, and so the confidence was relatively low. That's just if we do no optimization whatsoever and use the default prompts that DSPy generates for us. Given x and y, generate z, where it uses the built-in names that you told it. So to actually do a better job, we need to create a teleprompter. And so tele is the prefix that you hear in telephone and television, and so this means prompting at a distance. We are not going to prompt ourselves, but we will instruct a nice machine learning algorithm to do the prompting for us. And so here we say we're going to use the metric that I defined. So here we say we're going to use the metric that we defined before, validate answer, use 4 threads, then take the program that we defined with that forward function that I showed you, and look at the data set of the 1,000 quiz bowl questions and do the best you can. What it does is it tries out a bunch of prompts. Some of these are fun. Your retrieval augmented generation system expert tasked with generating the initial retrieval query for a RAG pipeline. Given the input question, produce a concise and effective query. And so on and so on, and then there are some more generic ones. Generate a query based on the input question and things like that. The one at the very top is the default DSPy prompt. This is the one that gave us the results that I showed you before. We're hoping that we can do better than that. The next step is to generate a guess, your best take on the answer. You are a sophisticated AI assistant designed to provide answers based on a given question and associated context. Your task is to analyze the provided question in context and then generate. And so these are all the things that get tried out. We then move on to the final stage, the confidence prompt. And here they're getting even funkier. For a prestigious international debate competition, you must accurately identify the key figure responsible for a pivotal historical event, specifically signing the Treaty of Versailles. And then it goes on. So these are all the things that it tries out. Let's see what actually won. This isn't just a coordinate-wise ascent, pick the best one of these. You need to try out all the different combinations of these things, and this isn't even the full set of all the prompts that it tried out. And so for the query, the generic one worked best apparently. Generate a query based on the given question. For the guess, your task is to generate a concise and accurate answer based on the provided context. Focus on extracting the most relevant information and presenting it clearly. Output the answer field directly. And for confidence, imagine a catastrophic event, a sudden unexplained disappearance of all historical records, yada yada yada. It goes on. But apparently this worked the best. And so, yeah, indeed, it did work quite a bit better. We had a negative overall score before. Now we have a positive score over our 100 questions. A couple of questions that were wrong before in the 10-question sample are now right. Good job. That being said, one that we did get correct before now is wrong, so we backslid a little bit there, but overall win. One thing that I was disappointed about is that the confidence actually got worse. We didn't provide enough clues in the metric to kind of point towards using the context effectively, and maybe we could have generated a couple more features along the way to help get the confidence calibrated correctly. And maybe I gave too much credit for getting the answer right. Obviously that's more important, but that was worth one, and the minor tweaks that you got for slightly shifting the confidence ended up mattering quite a bit less. To wrap up, feature engineering is new again, and so and a lot of the skills that you learn for feature engineering come into play here. You need to represent the sorts of things that you think are going to be important for the downstream prompt in a way that DSPy can access them and use them, or not, as it decides. The bigger question here is you need to figure out what you care about and to measure it. And that only happens if you understand the data and the problem. Hopefully this example has given you some ideas about how you could make this even better. Some things that come to my mind are giving more inputs for the confidence estimation. You could have multiple Muppet models, check whether they agree or not. Use more of the reasoning chain as part of the confidence estimation. We probably should have derived more features from the context, use that in the metric. Obviously, the underlying RAG system plays a big role. We probably should have tuned that a little bit better. Include bigrams, optimize for recall. Add in Wikipedia as a possible set. That was our brief introduction to automatic prompt engineering with DSPy. Hopefully you'll try it out on your own, and it's a lot of fun. Thanks for watching this video. I picked out another video that you could watch up here. If you want to get more context for the videos, check out this link or the link in the description. It gives you readings, programming assignments, and other things that might be more helpful. Finally, help me out and help other people find this content by providing a big gradient to the recommendation algorithm. Like the video, subscribe, or leave a comment down below with mistakes that I've made, newer research that has come out, or just tell me about where you are in your journey.